The morning of April 18th, 1943. 50 feet above the Solomon Sea, 18 Lockheed P-38 Lightnings screamed northwest at 280 miles per hour, their twin Allison engines drowning out everything except the pilot's racing thoughts. Major John Mitchell checked his compass for the 47th time in 90 minutes, calculating wind drift against fuel consumption, knowing that 1 degree of navigation error across 435 miles of featureless ocean would kill everyone in his formation. The Germans had a name for the P-38, der Gabelschwanz Teufel, the fork-tailed devil. But that name carried a backhanded compliment buried inside it. German fighter pilots and engineers had spent 2 years cataloguing the Lightning's flaws. The twin-boom design created excessive drag. The engines were too far from the pilot, making asymmetric thrust during single-engine operations nearly impossible to manage. The cockpit sat exposed between 2 massive sights, fire hazards. The superchargers failed at high altitude. The control surfaces locked up in high-speed dives due to compressibility. Every Luftwaffe tactical report from 1942 onward emphasized the same conclusion. The P-38 was fundamentally flawed, a mediocre fighter that American industrial capacity could afford to waste, but that no competent air force would have designed in the first place. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. And yet, right now, 16 of these supposedly flawed aircraft were executing a mission that no other fighter in the Pacific theater could attempt. They were flying further than their published combat radius, burning fuel at rates that shouldn't leave enough for the return trip, navigating with nothing but dead reckoning across an ocean that offered no landmarks, no radio guidance, no second chances. And they were doing it, to kill one man. Admiral Isoroku Yamamoto, architect of Pearl Harbor, commander of the Imperial Japanese Navy's combined fleet, was flying from Rabaul to Bougainville aboard a Mitsubishi G4M bomber. American codebreakers had intercepted his flight schedule. American intelligence had calculated his exact route, and now American fighters, these flawed, over-engineered, supposedly inferior P-38 seconds, were about to demonstrate that German tactical assessments meant nothing when physics and fuel and bullets converged at the right coordinates. The Lightning had been controversial from its first flight in January 1939. Lockheed's design team, led by Clarence Kelly Johnson, had responded to an Army Air Corps specification for a high-altitude interceptor capable of 360 miles per hour at 20,000 feet. The Army wanted performance that no single-engine fighter could deliver with existing engine technology. Johnson's solution was Radical Mount 2 Allison, V-17, 10 engines on twin booms extending back from the wings, place the cockpit and armament in a central nacelle between them, and use the boom-mounted tail surfaces to connect everything. The result looked like 2 aircraft welded together with a bathtub in the middle. Army test pilots who flew the prototype in 1939 immediately noticed problems. The control yoke required constant pressure to maintain coordinated flight. Lose one engine, and the asymmetric thrust tried to flip the aircraft inverted. The superchargers, which provided high-altitude performance, were temperamental and prone to failure. And the aircraft's smooth metal skin produced a phenomenon nobody had predicted in high-speed dives, approaching 400 miles per hour. Airflow over the wings created shock waves that locked the control surfaces. Pilots couldn't pull out of the dive. Several test aircraft augured into the ground before engineers understood what was happening. Compressibility. The Lightning was fast enough to encounter transonic effects that wouldn't be fully understood until jets arrived. The solution involved dive flaps and careful pilot training about speed limits in descents, but the problem revealed something fundamental about the P-38's design. It was so fast, so powerful, that it pushed into flight regimes where aerodynamics stopped behaving predictably. German engineers studying captured Lightning wreckage in North Africa during 1942 noted this issue with something approaching professional respect. The Americans had built a fighter that exceeded the limits of their own understanding. But speed meant nothing if the engines quit. and the Allison V-1710 had a deserved reputation for fragility. 12 cylinders arranged in a 60-degree V configuration, liquid-cooled, producing 1,150 horsepower at takeoff. In European weather, the cooling system froze. In Pacific humidity, it corroded. The reduction gearbox that connected the engine to the propeller wore out faster than maintenance schedules predicted. And the turbo supercharger, the component that gave the Lightning its high-altitude performance, failed so regularly that ground crews kept spares stacked like firewood. German pilots shot down dozens of P-38 seconds over North Africa and Europe in 1942 and 1943. Luftwaffe tactical intelligence compiled detailed reports on how to exploit the Lightning's weaknesses. Attack from above, the P-38's rate of climb was inferior to the Focke-Wulf 190 and Messerschmitt 109. Force it into turning combat, the wide-set engines created moment arms that made tight turns sluggish. Target, the engine's knockout one, and the asymmetric thrust would do the rest. The reports concluded that while the P-38 was dangerous in specific circumstances, high-altitude interception, hit-and-run attacks using superior speed, it could not compete with purpose-built single-engine fighters in sustained combat. These assessments weren't wrong, exactly. They were contextual. The Lightning struggled in the European theatre because Luftwaffe pilots had 2 years of combat experience and flew aircraft optimized for medium-altitude fighting over predictable geography. But the Pacific theatre presented completely different requirements. Range mattered more than maneuverability. Navigation over featureless ocean mattered more than dogfighting skill. Reliability of 2 engines mattered more than the theoretical elegance of one. And raw speed mattered because Japanese fighters, while incredibly maneuverable, were slow and fragile compared to American designs. The mission to kill Yamamoto crystallized everything the P-38 could do that no other fighter could. The Curtiss P-40, which equipped most American fighter squadrons in the Pacific during early 1943, had a combat radius of about 200 miles. The Republic P-47, just arriving in theatre, could manage maybe 300 miles with external tanks. The Navy's Grumman F-6F Hellcat was carrier-based and irrelevant for a land-based interception. Only the P-38, with its massive internal fuel capacity and space for enormous external drop tanks, could cover 435 miles to the interception point, fight, and return home. Major John Mitchell had calculated the fuel requirements down to the gallon. Each P-38 Lightning carried 410 gallons internally, 100 in fuselage tanks, 310 split between wing tanks. The Army had rushed to develop 310-gallon external tanks specifically for this mission's range requirements. With 2 external tanks, each Lightning carried a total of 1,030 gallons, enough for approximately 5 hours of flight at cruise power settings. The math was brutal. 435 miles at 250 miles per hour meant 1 hour and 45 minutes to the target area. Another 1 hour and 45 minutes back, 3.5 hours just for transit, add 20 minutes for combat maneuvering, and the mission required 3 hours and 50 minutes minimum. At cruise power, each Allison engine burned approximately 85 gallons per hour. 2 engines, 85 gallons each, meant 170 gallons per hour total. 3 hours and 50 minutes at 170 gallons per hour equaled 653 gallons. They had 1,030 gallons, 653 gallons needed. That left 377 gallons of margin, except that didn't account for headwinds, or climbing to altitude during combat, or running the engines at high power during the attack, or the possibility that some drop tanks wouldn't feed properly, which happened regularly with external tanks in 1943. The real margin was probably closer to 100 gallons, maybe 50, maybe 0 if anything went wrong. Mitchell briefed his pilots on April 17th and watched their faces process the fuel calculations. These weren't rookie pilots. They understood what flying beyond published combat radius meant. One navigation error missing Bougainville by even 10 miles, and they'd exhaust fuel searching for the target. One stuck drop tank valve, and that pilot would run dry 50 miles from Guadalcanal. One unforecasted headwind, and everyone swam. Captain Thomas Lanphier, assigned to lead the four-plane killer flight that would directly attack Yamamoto's bomber, asked the obvious question: what if we can't drop the external tanks before combat? Mitchell's answer was blunt: then you're too heavy to fight and you'll die. The P-38 with full external tanks was a pig, slow, unresponsive, vulnerable. The tanks had to come off before engaging enemy fighters, but dropping them early meant less fuel. The timing had to be perfect. The intelligence was gold. Navy codebreakers working at Fleet Radio Unit Pacific, the team that had provided Admiral Chester Nimitz with Yamamoto's complete battle plan before Midway, had cracked Japanese naval code JN 25 months earlier. The April 13th intercept contained extraordinary detail. Yamamoto would depart Rabaul at 6 a.m. Local time on April 18th aboard a Mitsubishi G-4M bomber, escorted by 6 Mitsubishi A-6M0 fighters. Flight time approximately 2 hours. Arrival at Balali Airfield near Bougainville at approximately 8 a.m. American intelligence officers studied every word of that decrypt, looking for signs of deception. Was it too perfect? Could the Japanese be setting a trap, using false communications to lure American fighters into an ambush? The assessment came back negative. The message traffic matched normal Japanese communication patterns. The routing was consistent with Yamamoto's known schedule of frontline inspections, and critically, the Japanese had no reason to suspect their codes were compromised. They'd changed JN25 ciphers several times, but American cryptanalysts had broken each iteration within weeks. The Japanese believed their communications were secure. Secretary of the Navy Frank Knox personally authorized the mission after consulting with President Franklin Roosevelt. The decision carried enormous risk. If the mission failed and pilots were captured, interrogation might reveal that American intelligence could read Japanese codes. If Japan discovered the compromise, they'd change their encryption systems immediately, blinding American intelligence across the entire Pacific. Every intercepted message since Midway, every convoy route, every operational plan, every ship movement had depended on cracking JN25. One failed assassination could shut down the most valuable intelligence source America possessed. Roosevelt reportedly said 3 words: "Get the bastard." The moral calculation was simple. Yamamoto had planned Pearl Harbor. 2,400 Americans had died on December 7th, 1941. Revenge mattered, but strategy mattered more. Yamamoto was irreplaceable, the only Japanese naval officer who'd studied at Harvard, served as naval attaché in Washington, and deeply understood American industrial capacity. He'd opposed war with the United States precisely because he knew Japan couldn't win a prolonged conflict. But when ordered to fight, he'd executed brilliant operations that nearly knocked America out of the Pacific. His death would remove that strategic brilliance from Japanese decision-making. His successors would be competent, but conventional. They'd follow doctrine instead of rewriting it, and doctrine wouldn't save Japan from the industrial hurricane America was unleashing. The mission authorization arrived at Guadalcanal on April 14th. Major Mitchell immediately began mission planning with a precision that would determine whether 18 pilots came home or died in the ocean. He calculated compass headings, accounting for magnetic variation. He plotted waypoints against maps that were barely accurate, based on aerial reconnaissance photos that showed coastlines but not much else. He studied weather forecasts predicting wind speed and direction at different altitudes, and he rehearsed the navigation timing over and over until he could recite bearing changes and leg durations from memory. The route would take them west-northwest from Guadalcanal, staying over water to avoid Japanese radar stations on New Georgia and Vella La Vella. They'd fly at 50 feet above sea level, low enough to stay under enemy radar coverage, high enough to avoid waves in rough seas. Navigation would be entirely by dead reckoning. No radio beacons, no landmarks, just compass, airspeed, and time. Mitchell would lead, checking his heading every few minutes against a plotting board strapped to his knee. The other 17 pilots would maintain visual formation with him, trusting his navigation implicitly. At 9:33 a.m. Bougainville time, accounting for the 1-hour time zone difference between Guadalcanal and Bougainville, the formation would climb to 5,000 feet and look for 2 Mitsubishi G-4M bombers approaching Belal. The killer flight would drop external tanks and attack. The remaining 12 P-38 seconds would fly high cover, engaging the Zero escorts and any other Japanese fighters that appeared. After the attack, the formation would run southeast, back toward Guadalcanal, with whatever fuel remained. Mitchell estimated they'd land with approximately 30 minutes of fuel remaining. 30 minutes. That was the margin between success and swimming. The Germans would have called the plan insane. No Luftwaffe commander would risk 18 fighters on a single target assassination when those fighters represented irreplaceable combat power. German doctrine emphasized force preservation. You don't gamble your strength on putting low-probability missions, no matter how valuable the target. But American doctrine in the Pacific was different. America had industrial capacity to replace lost aircraft within weeks. Japan didn't. Trading 18 P-38 seconds for Yamamoto's life was mathematically sound, even if the mission only had a 50% success probability. The aircraft themselves received extraordinary preparation. Ground crews worked through the night of April 17th, checking every rivet, every fuel line, every engine cylinder on all 18 Lightnings. They hand-cranked engines to verify compression. They tested magnetos and spark plugs. They examined propeller blades for cracks. They loaded 4 50-caliber machine guns and 1 20mm cannon in each aircraft's nose, 300 rounds for each machine gun, 60 rounds for the cannon. The combined weight of firepower was devastating at close range. A 2-second burst put approximately 140 rounds into the target area. The external drop tanks arrived from the depot on Espiritu Santo, aboard a transport flight that afternoon. Ground crews bolted them to hardpoints under each wing, then tested feed systems to ensure fuel would transfer properly to internal tanks. The tanks were aluminum, riveted construction, ugly and asymmetric compared to the sleek P-38 airframe, but they carried 310 gallons each, and without them the mission was impossible. Pilots attended final briefing at 6 p.m. on April 17th. Mitchell spread maps across a plywood table in the operations tent and walked through the mission timeline step by step. Wheels up at 7:25 a.m. Departure heading 280 degrees. First leg 112 miles to position coordinates. Then turn to 315 degrees for the long leg to Bougainville. Estimated time to interception point, 1 hour 45 minutes. Rules of engagement. Destroy both. Bombers, confirm kills, disengage and return to base. Rex Barber, assigned to the killer flight, asked about identification. How would they know which bomber carried Yamamoto? Intelligence believed he'd be in the lead bomber, but Japanese formation doctrine was flexible. Mitchell's answer was simple. Shoot both of them. That night, pilots wrote letters they might never mail. Some slept. Others sat outside their tents, smoking cigarettes and watching stars wheel overhead, thinking about fuel calculations and navigation, and the fact that in 12 hours they'd either be heroes or statistics. The jungle around Henderson Field hummed with insects. Japanese positions at the northern end of Guadalcanal were maybe 30 miles away, close enough that occasionally you could hear artillery fire at night. And 600 miles northwest at Rabaul, Admiral Yamamoto was presumably sleeping peacefully, unaware that 18 American fighters and 36 Allison engines were about to prove that German assessments of the P-38's flaws didn't matter at all. The engines coughed to life at 7:15 a.m. on April 18, 1943. 18 Lockheed P-38 Lightnings, each carrying 1,030 gallons of high-octane aviation fuel, began their run-ups along Henderson Field's packed coral runway. The sound was overwhelming 36 Allison V-1710 engines, 432 cylinders firing in sequence, creating a wall of noise that drowned out thought itself. Rex Barber ran through his checklist with mechanical precision. Fuel selector valves, external tanks feeding first, mixture full rich for takeoff, propeller pitch full forward, throttles advancing smoothly, oil pressure climbing into the green. His hands moved across the cockpit by muscle memory, touching switches and levers in the sequence he'd practiced hundreds of times. The P-38 vibrated beneath him, the twin booms shuddering as the Allisons reached full power. At 7:25 precisely, Major John Mitchell released his brakes and began his takeoff roll. The Lightning accelerated slowly, heavy with fuel and ammunition. The coral surface blurred beneath him. At 130 miles per hour, he pulled back on the yoke, and the aircraft lifted reluctantly into humid tropical air. 17 more P-38 seconds followed at 15-second intervals. Within 5 minutes, all 18 were airborne and forming up over Guadalcanal's southern coast. One Lightning immediately developed problems. Lieutenant Joe Moore's drop tanks refused to feed. He tried switching valves, adjusting fuel pressure, everything the manual suggested. Nothing worked. His internal tanks showed fuel draining while the externals stayed stubbornly full, which meant he'd run dry long before reaching Bougainville. He waggled his wings, the signal for mechanical trouble, and peeled away, heading back to Henderson Field. The mission was down to 17 aircraft. Mitchell led the formation northwest, climbing initially to 10,000 feet before bringing them down to wavetop level. The transition from altitude to 50 feet above the ocean was psychologically jarring. At 10,000 feet, you had time to react to problems. At 50 feet, one moment of inattention meant your propellers kissed salt water at 250 miles per hour and the ocean swallowed you before your brain registered the error. The P-38's twin boom configuration actually helped at extreme low altitude. The cockpit sat high between the booms, giving pilots slightly better visibility than single-engine fighters where the nose blocked your view. But that advantage meant nothing if you misjudged your height by even a few feet. The ocean rushed past underneath in a blue-grey blur. No time to think. Just fly instruments, trust your eyes, and hope. 40 minutes into the flight, Lieutenant Jim McClanahan's drop tanks developed the same feeding problem that had forced Moore to abort. He went through the troubleshooting steps, checked valves, adjusted pressure. Nothing changed. His fuel gauges showed internal tanks draining while external tanks stayed full. He had maybe 90 minutes of fuel remaining, enough to reach Bougainville, but nowhere near enough to make it home. He waggled his wings and turned back. Now the killer flight was down to 2 aircraft, Thomas Lanphier and Rex Barber. 2 P-38 seconds to find and destroy 2 Japanese bombers escorted by 6 Zeros. Mitchell briefly considered aborting. 2 planes seemed inadequate for the mission profile, but they were already 150 miles from Guadalcanal, burning fuel that couldn't be replaced, and intelligence this good appeared maybe once in a war. He continued. The formation settled into the monotony of overwater navigation. Blue water below, blue sky above, the sun climbing steadily toward its noon zenith. No landmarks, no reference points. Just Mitchell's compass and his calculated headings. Pilots fought. Drowsiness from the engine drone and the benzodrine wearing off most had taken amphetamine pills before the mission to stay alert during the long overwater flight. The Germans had specific tactical recommendations for fighting P-38 seconds, documented in Luftwaffe intelligence bulletins distributed to fighter units throughout Europe. The Lightning pilot sits exposed between 2 engines and fuel tanks, one report noted. Fire into the central nacelle achieves maximum effect. The aircraft's wide configuration makes deflection shooting easier than against compact single-engine fighters. In turning combat, the Lightning is sluggish. A Messerschmitt 109 or Focke-Wulf 190 can outturn it at all altitudes below 20,000 feet. But those assessments assumed combat over Europe, where Luftwaffe pilots could dictate terms of engagement. The Pacific theater offered different physics. Japanese Zeros could absolutely outturn a P-38 inches horizontal, maneuvering the Zero's light. Wing loading and responsive controls made it one of the most maneuverable fighters in the world. But the Zero's light construction meant it was fragile, and its single Nakajima-Sakai engine meant engine failure was death. The P-38 pilot who lost one engine could still fly home on the other. The Zero pilot with engine damage glided into the ocean and died. At 9:33 a.m. Bougainville time, 1 hour and 43 minutes after takeoff, the formation spotted land. A thin grey line on the northwestern horizon, barely visible through haze. Bougainville. Mitchell checked his watch and his position. They were 2 minutes early and roughly 5 miles south of the planned interception point. 435 miles over featureless ocean, and he'd hit his mark within 2 minutes and 5 miles. It was extraordinary navigation that would determine the mission's success. Mitchell signaled the formation to turn north and climb. The top cover flight 12 P-38 seconds under his. Command followed him up to 18,000 feet. Lanphier and Barber stayed low, accelerating toward the coast. Their drop tanks were still attached, adding drag and weight. They'd need to jettison them before combat, but not yet, not until they spotted the target. At 9:34 a.m., Doug Canning in Mitchell's flight spotted aircraft. 2 large bombers in shallow descent toward Balali airfield, exactly as intelligence had predicted. 6 fighters flying cover above them in 2 3-plane elements. The Japanese were precisely where they were supposed to be, when they were supposed to be there. Yamamoto's obsession with punctuality had delivered him to his execution with perfect timing. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Lanphier rocked his wings, the signal for enemy sighted, and pushed his throttles forward. Barber followed, closing the distance. The range was about 10 miles and shrinking fast. The P-38 seconds were at 50 feet, accelerating toward the coast at over 300 miles per hour. The Betty bombers were at 4,500 feet, descending. The geometry was perfect for an attack. Then the Zero pilots spotted them. 6 Japanese fighters dropped their external fuel tanks and dove toward the American fighters. Above them, Mitchell's cover flight engaged, 12 P-38 seconds climbing to meet the diving Zeros. The sky filled with aircraft turning, diving, firing. Suddenly, the carefully planned attack profile disintegrated into chaos. Lanphier pulled up to meet the Zeros head-on, his guns firing in short bursts. Barber stayed low, continuing toward the bombers. The killer flight was supposed to attack together while the cover flight held off the escorts. But combat plans collapse the moment enemy fighters appear, and training gives way to instinct. The Betty bombers broke formation. The lead bomber later, identified as carrying Yamamoto, turned hard left toward the jungle, descending rapidly. The second bomber turned right, heading for cloud cover over the ocean. Barber locked onto the left-hand Betty, the one diving for the trees. He closed to 500 yards, then 300, then 100. His gun sight centered on the bomber's fuselage. The Betty's tail gunner opened fire. 20mm cannon shells arcing toward Barber's P-38. He ignored them, concentrating on his target. At 100 yards, he pressed the trigger. 4 50-caliber machine guns and 1 20mm cannon erupted. The combined firepower, approximately 200 rounds per second, tore into the Betty's right engine and wing root. German tactical assessments had noted that the P-38's nose-mounted armament created a tight convergence pattern that was devastating at close range. All 5 guns fired along the aircraft's centerline, meaning the pilot simply pointed the nose at the target and everything converged at the same point. No need to calculate convergence angles like with wing-mounted guns. The Betty's right engine exploded in a ball of orange fire. The wing folded upward, broken by the sheer kinetic force of Barber's guns. The bomber rolled inverted and plunged into the jungle canopy at over 200 miles per hour. Barber flashed overhead, pulling up hard to avoid flying through the explosion. He caught a glimpse of wreckage tumbling through trees, then he was past, climbing, searching for threats. Behind him, black smoke marked where Yamamoto's aircraft had died. Lanfear, meanwhile, had tangled with the Zeros. He'd fired at one, claimed hits, then dove away and spotted a Betty bomber below him. He attacked from above and behind, fired a long burst, saw the bomber smoking. Then his aircraft shuddered, Zero fire had hit him. He dove for the deck, running for the ocean at full throttle with 2 Zeros pursuing. His P-38 was damaged, one engine running rough, but still flying. Lieutenant Besby Holmes, flying in the cover flight, spotted the second Betty, heading out over the ocean. He chased it, firing sustained bursts until the bomber's left engine caught fire and the aircraft nosed into the water 3 miles offshore. The Betty hit belly first, then cartwheeled and broke apart. The ocean swallowed it in seconds. 2 bombers, 2 kills. The entire engagement, from first sighting to final crash, lasted less than 4 minutes. 4 minutes of violence compressed into a tiny piece of sky above Bougainville's southern coast. And somewhere in the wreckage, burning in the jungle below, Admiral Isoroku Yamamoto was dead. The P-38 seconds disengaged and ran for home. Mitchell's voice crackled over the radio first transmission of the mission, calling everyone to break off and head southeast. The Zeros pursued for 20 miles, firing long, desperate bursts that fell away into empty air. The Lightnings had speed, and eventually the Japanese pilots gave up and turned back toward Bougainville. The return flight was brutal. Every pilot nursed his fuel, leaning the mixture to the ragged edge of engine roughness, watching gauges drop toward empty. The external tanks were long gone, jettisoned before combat. Now they flew on internal fuel only. The math that had been tight on the way out became desperate on the way back. The Germans had criticized the P-38's fuel consumption. The twin-engine configuration burns fuel at nearly double the rate of comparable single-engine fighters. One Luftwaffe assessment noted. This limits operational range despite large fuel capacity. That criticism was accurate in European combat, where missions rarely exceeded 200 miles from base. But in the Pacific, where distances were measured in hundreds of miles over open ocean, having 2 engines meant having redundancy. Lose 1 engine, and you still flew home. Single-engine fighters ditched and their pilots drowned. 2 P-38 seconds didn't make it. They ran dry, 50 miles from Henderson Field, and ditched in the ocean. Navy PT boats rescued both pilots sunburned, exhausted, but alive. The other 14 aircraft landed at Guadalcanal between 12:15 and 12:30 p.m., their fuel gauges showing 0 or near 0. Ground crews swarmed the planes, helping pilots out of cramped cockpits. Mitchell confirmed both bombers destroyed, but couldn't say for certain which one had carried the Admiral. That information would take time to verify. For now, all they knew was the mission had succeeded tactically. They'd found the target. They'd executed the attack. They'd survived. The Japanese search party found the wreckage on April 19th, less than 24 hours after the crash. Local troops hacked through dense jungle, guided by smoke still rising from the impact site. What they discovered scattered across 200 yards of shattered trees was carnage. The Betty bomber had disintegrated on impact, flinging debris and bodies through the foliage. Admiral Yamamoto's body was located in the jungle undergrowth, still strapped to his seat, thrown clear when the fuselage broke apart. His white dress uniform was stained with blood from 2 bullet wounds, one in his left shoulder, one in his left jaw. Both wounds tracked from front to back and slightly downward, consistent with being fired from an aircraft attacking from behind and slightly above, exactly the attack geometry Barber had used. The Army surgeon who examined the body noted the wounds matched small-caliber aircraft gunfire, 50 caliber or 20 millimeter rounds. Death had been instantaneous or near instantaneous. Yamamoto probably never knew the P-38 seconds were coming until the first bullets hit. Tokyo faced an immediate dilemma. Yamamoto's death was a catastrophic blow to military morale and national prestige, but announcing it immediately would raise uncomfortable questions. How did American fighters know exactly where to find him? How did they intercept his plane so far from Allied bases? Were the codes compromised? The Imperial General Headquarters decided on silence. They retrieved Yamamoto's body, cremated it, and said nothing publicly while they investigated the security breach. For 36 days, Japan's leadership maintained the fiction that Yamamoto was alive and actively commanding naval operations. The Americans, meanwhile, were desperate to confirm the kill, but couldn't announce it without revealing their code-breaking capabilities. If Japan realized JN-25 was compromised, they'd change their codes overnight and blind American intelligence across the entire Pacific. So Washington stayed silent too, waiting for independent confirmation. The confirmation came through Australian coast watchers, Solomon Islanders, working behind Japanese lines, who reported everything they saw to Allied intelligence via hidden radios. On April 20th, a coast watcher near Bougainville reported increased Japanese military activity and rumours of a high-ranking officer killed in an air crash. On May 10th, another report mentioned a major funeral ceremony at Rabaul. On May 21st, Tokyo Radio finally announced that Admiral Yamamoto had died heroically in April while directing operations at the front. The broadcast didn't mention he'd been shot down. It implied he'd died in combat, perhaps during a naval engagement, protecting his reputation and avoiding the embarrassing truth that American fighters had assassinated him in broad daylight. American newspapers exploded with the story on May 22nd. Headlines screamed about Yamamoto's death and the daring long-range fighter mission that killed him. The Navy Department released carefully sanitized details. P-38 Lightnings from Guadalcanal had intercepted Japanese bombers near Bougainville on April 18th and destroyed both aircraft. The press release didn't mention code breaking, didn't mention the intercepted itinerary. As far as the public knew, it was skilled flying and good fortune. The truth would remain classified for decades. The question of credit became immediately controversial. Lanfear's initial combat report claimed he'd attacked a Betty bomber from above, set it on fire, and watched it crash into the jungle. Barber's report claimed he'd pursued a Betty at low altitude, destroyed its right engine and wing, and watched it cartwheel into the trees. Both descriptions matched the crash site where Yamamoto's body was found. Both pilots claimed the kill. The Army Air Forces faced a problem. 2 pilots, 1 confirmed kill, and no objective way to determine who deserved credit. The official solution was a compromise that satisfied nobody. The AAF credited Lanfear with destroying Yamamoto's bomber, and credited Barber with destroying the second bomber that crashed in the ocean. Even though Besby Holmes had clearly shot down the ocean, Betty and multiple witnesses confirmed it. This arrangement gave Lanfear the glory of killing Yamamoto, while giving Barber a consolation prize that didn't match what actually happened. Barber protested immediately. He knew what he'd shot, knew what he'd seen, but the AAF had made its decision. Lanfear leveraged his official credit brilliantly. He toured the United States, giving speeches, sold war bonds, met with politicians and celebrities, told and retold the story of how he'd personally killed the architect of Pearl Harbor. The press loved him. The public loved him. He became the face of Army Air Force's fighter operations in the Pacific. Barber, meanwhile, returned to Oregon after the war and tried to resume normal life. He didn't give speeches. He didn't seek publicity. He just quietly insisted to anyone who asked that he'd shot down Yamamoto's bomber, and the official record was wrong. The controversy simmered for decades. Historians investigated, interviewed surviving pilots, analyzed what gun camera footage existed, studied Japanese records of the crash site. The evidence gradually shifted toward Barber. The bullet wounds on Yamamoto's body matched an attack from behind and below Barber's approach. The wreckage pattern suggested catastrophic structural failure of the right wing, consistent with Barber's sustained fire into that wing route. By the 1980s, most serious historians concluded Barber had shot down Yamamoto, but Lanphier never admitted it. He maintained his story until his death in 1987. Barber lived until 2001, long enough to see historians vindicate his account, but not long enough to see the official record changed. The Air Force still credits Lanphier with the kill in some official histories, though most acknowledge the controversy and note that evidence supports Barber. It's an unsatisfying conclusion to an extraordinary mission, the most important fighter interception of World War II, forever tainted by disagreement about who actually pulled it off. But the larger truth transcended individual credit. The mission succeeded because the supposedly flawed P-38 Lightning did something no other fighter in the Pacific could do. It flew further than its published combat radius. It navigated across featureless ocean with dead-reckoning precision. It fought at the end of a 1,000-mile round trip. And it brought its pilots home. The Germans had catalogued the Lightning's flaws correctly. The twin-boom design did create drag. The engines were far from the pilot. The superchargers did fail regularly. Compressibility did lock the controls in high-speed dives. Every criticism was accurate. But those flaws didn't matter when the mission required range above all else. The P-38's twin engines and massive fuel capacity gave it capabilities that single-engine fighters simply couldn't match. The flawed design was actually optimized for Pacific theater requirements long over water flights, engine redundancy, heavy armament, and the ability to maintain high speed at altitude. Japan never recovered from losing Yamamoto. Not strategically, the loss of 4 carriers at Midway had already crippled their offensive capabilities, but psychologically. Yamamoto had been the Empire's talisman, the genius admiral who understood modern warfare, the leader soldiers believed could pull victory from impossible odds. His death shattered that belief. The officers who replaced him were competent but conventional. They followed doctrine instead of rewriting it. They executed plans instead of creating brilliant new ones. The Imperial Navy's operational tempo slowed noticeably after April 1943. Fewer aggressive sorties, more defensive posturing. A creeping sense that initiative had permanently shifted to the Americans. Vice Admiral Jisaburo Ozawa, who inherited command of the combined fleet, was a capable officer but lacked Yamamoto's strategic vision. Where Yamamoto had orchestrated complex multi-carrier operations spanning thousands of miles, Ozawa focused on preserving his remaining ships. Preservation meant survival, but guaranteed defeat. You can't win a war by not losing. American forces exploited the vacuum ruthlessly. Admiral William Halsey's South Pacific campaign accelerated immediately after Yamamoto's death. New Georgia fell in August 1943. Bougainville, the very island where Yamamoto died, was invaded in November. The Japanese couldn't mount effective counterattacks because their naval air groups had been gutted at Midway and their leadership was paralyzed by caution. The psychological impact rippled through Japan's entire military structure. Yamamoto had been proof that Japan could compete with Western powers through superior spirit and clever strategy. His death suggested maybe they couldn't. Maybe American industrial might and technological superiority would grind them down regardless of how cleverly they fought. The Americans turned Yamamoto's death into a massive propaganda victory. Once Tokyo announced it, U.S. newspapers published detailed accounts of the mission. Magazine articles celebrated the P-38 pilots who'd flown 1,000 miles to execute Japan's greatest admiral. Newsreels showed P-38 seconds taking off from Pacific bases, dramatizing the long-range interception. The message was clear. America could reach anywhere, kill anyone, no matter how far behind enemy lines they hid. If the architect of Pearl Harbor wasn't safe, nobody in the Japanese military was safe. The battles that followed Philippine Sea in June 1944, Leyte Gulf in October 1944, were catastrophic Japanese defeats. The Navy lost 3 more carriers at Philippine Sea, along with hundreds of irreplaceable pilots. Leyte Gulf cost them 4 carriers, 3 battleships, and effectively destroyed the combined fleet as a fighting force. Would Yamamoto have prevented those disasters if he'd lived? The material imbalance was too severe, but he might have extracted a higher price from American advances. His successors fought conventionally. Yamamoto had specialized in the unconventional, the surprising, the attacks nobody expected. The island-hopping campaign that defined 1944 and early 1945 proceeded with mechanical efficiency. Saipan fell in July 1944, giving the Americans air bases within B-29 range of Tokyo. Iwo Jima fell in March 1945, providing emergency landing fields for damaged bombers. Okinawa fell in June 1945 after 3 months of horrific fighting. Each island brought American forces closer to the Japanese home islands and made the eventual invasion or surrender more inevitable. Japan's military leadership knew they were losing but couldn't find a way to stop it. They'd lost their strategic genius in April 1943, and everything afterward was just momentum carrying the war to its inevitable conclusion. There's a haunting counterfactual buried in Operation Vengeance. If Barber's bullets had missed by 6 inches, if Yamamoto's pilot had turned right instead of left, if the drop tank malfunctions had forced mission cancellation, would the war have ended differently? Probably not fundamentally different. American industrial production would still have overwhelmed Japan. The atomic bombs would still have been developed and likely used. But the path might have been longer, bloodier, more costly in American lives. Yamamoto was the one Japanese leader who understood American capabilities and might have crafted defenses that extracted maximum casualties from every island invasion. His death removed that brilliant defensive mind from the chessboard. What followed was brutal attritional warfare, where Japan lost every exchange because they simply had less to lose with. The Germans continued criticizing the P-38 throughout the war. Luftwaffe intelligence bulletins from 1944 still noted the Lightning's poor turning performance, its vulnerability to engine damage, its tendency toward compressibility problems in dives. Those criticisms remained valid in European combat, but in the Pacific, the P-38 became the highest-scoring American fighter type. Major Richard Bong scored 40 confirmed kills flying Lightnings. Major Thomas Maguire scored 38. The airplane's range, firepower, and twin-engine reliability made it ideal for Pacific operations. The supposed flaws that German engineers identified weren't design mistakes. They were trade-offs. Kelly Johnson and his Lockheed team had sacrificed maneuverability and simplicity for range and firepower. In Europe, where combat occurred over short distances and maneuverability mattered most, those trade-offs hurt the P-38's effectiveness. In the Pacific, where combat occurred over vast distances and range mattered most, those same trade-offs made the Lightning irreplaceable. The mission to kill Yamamoto proved that engineering is contextual. There's no such thing. As a universally flawed design only designs optimized for specific requirements. The P-38 was optimized for exactly the kind of mission that killed history's most important naval strategist. Twin engines for redundancy, massive fuel capacity for range, nose-mounted guns for concentrated firepower, and enough speed to outrun anything that couldn't outturn it. 18 P-38 Lightnings took off from Henderson Field on April 18th, 1943. 16 completed the mission. 14 returned safely. 2 ditched at sea and their pilots were rescued. 1 enemy admiral died in the jungle with 2 bullet wounds in his body. The Germans called the design flawed. The Japanese called it the fork-tailed devil. But the pilots who flew it called it the plane that won the Pacific, one impossible mission at a time. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.